Alright, this presentation is probably the most challenging one that I'm going to do. And it's not that bad, it's just a lot of steps to remember. So going into this presentation, keep in mind there's a lot to write down, and if you miss a step, it's really easy to mess up. That being said, let me show you how to balance a redox reaction. Redox reactions are complex equations. You have electrons being transferred. And if you can balance them by sight, because they're simple, that's great. But most of the ones that we're going to look at in this section, this chapter, are not equations that you'll be able to balance by sight. You're going to have to use this lengthy process here on this screen and work through a series of steps in order to make them balance. I promise you, there is no easy way to look at a balance or look at a redox equation and balance it on your own, unless it's one of the simple ones where you can see that, silver changes to copper kind of deal. All right, so the first step is you're going to use the half reaction method, and this has a process. Make sure that you write all these steps down, but also hear me what I'm saying. All right, so step number one, once you've decided that you need to do a balanced redox reaction, is you need to find the oxidation numbers. That is the charges. I suggest that you write them above the particular element that you're being given to. You need to be able to, number two, you need to be able to decide which one is oxidation and which one is reduction, because you need to break the whole reaction into your two half steps. You can't do that unless you can see the charges. Some of the problem is that you can't tell exactly what's changing to what. So maybe you have I2 on one side of the reaction, and over here you have like Ki. So you're going to be looking at, for instance, that I2 would be going from a 0 charge to a -1. But sometimes both your reduction and oxidation pieces are combined into a compound together. It doesn't work here with the example I gave, but if I had given you like CuI, this copper could be changing, and so can this iodine. So that's where some of the confusion lies. Step number three is we're going to break it into the half reactions, and you're going to balance the atoms that are not oxygen and hydrogen. So if you need to have 3 chromiums or you need to have 2 sulfurs, you're going to go ahead and balance all those pieces. Do not worry about the oxygen and the hydrogen at this step, because there's a whole bunch more that we're going to be doing with oxygen and hydrogen later. Okay, step number 4 is the critical piece. This is a piece that a lot of the folks mess up when they're doing their equations. When you break it into half reactions and you balance everything other than hydrogen and oxygen, the next step is that you need to figure out where the electrons are, how many of them are moving, and then you have to balance them. So let's say in our reduction we have a transfer of 2 electrons, and in our oxidation we have a transfer of 5. Well, you have to balance those electrons by coming up with a common multiple. And so the common multiple in this case would be 10. So that means that one half of our reaction we'd multiply by 5, and the other half we'd multiply by 2. Make sure that you balance your equation, your electrons at this point. Okay? The next step after that is you have to make a choice, and this isn't a choice that you make, it's a choice made for you based on the information in the problem. You're either going to balance this in an acid or you're going to balance it in a base. If you're balancing in an acid, you're going to do the steps in this order. You're going to then balance your oxygens by adding H2O and your hydrogens by adding H plus on the appropriate side of the half reactions for both sides. And then you're done, basically. You have to then add those two half reactions together and then cancel out the pieces that are on both sides of the reaction. If you're working with a base, you have a slightly different sequence. For the oxygens, you have to add OH, but in order to make it work, you have to add 2 times the OH. So if you need 2 O's, you're going to add 4 OHs. You're going to balance out your hydrogens by adding H2O. And then just like in the acid situation, you're going to add your 2 reactions together and cancel out similar species. So it can be complex, but there is a sequence and you cannot do them out of order. Okay, so make sure that you get this sequence written down, that you follow it for the practice that we're going to be doing over the next few days. The next screen, I have a sample problem for us to balance that is one of these complex redox reactions. All right, here's our sample problem. You see MnO4 minus and SO2 reacting to form Mn plus 2 and SO4 minus 2. And this one is in acid. So, step number 1, figure out our charges. I see over here that my Mn is, in one case, I know it's not plus 2 on the left, but over here it's a plus 2. So I have minus on the overall charge, and I have 4 oxygens, so that's -8. And I want to have an overall -1, so that means that my Mn is a plus 7. I have on the left, I have S is a plus 4. And on the right, I have my S is a plus 6. So I can see how I'm going to break this into my half reactions. I have my MnO4 minus is going to break into Mn plus 2. And I have my SO4, I'm sorry, it's not a 4, it's an SO2. SO2 makes SO4 minus 2. Alright, step number 1. Balance anything that's not O's and H's. And my MNs and my S's are balanced. All right, now we need to figure out the transfer of electrons. And when you do that, you go back, you don't look at what you have written on your screen or at the half reactions. You go back and look at the overall oxidation state. So Mn is going from a 7 to a 2. And so to get from a plus 7 down to a plus 2, you have 5 electrons. We are going to need the 5 electrons to be on this side because we are going from plus 7 down to plus 2. In the case of the SO2, we are going from a plus 4 to a plus 6. So we're actually increasing our electrons, or we're increasing our charge, so we're losing some electrons. So on this side, we're going to put our 2 electrons. The next step is to balance the electrons. So you can see here that we have a transfer of 5 electrons on one side and 2 electrons on the other side. So we need to make this so that it's 10 overall. So that means up here on the first line, we're going to multiply by 2, and on the second line, we're going to multiply by 5, which means we have our 10 electrons overall. Okay, so when I rewrite this, I'm going to go back to the black because I think it's easier to see. We're going to have our 2 MnO4 minus and 10 electrons, making 2 Mn plus 2. And our next line down, we're going to have 5 SO2, making 5 SO4 minus 2s and 10 electrons. This problem is telling me that this is an acid. I'm going to go ahead and draw a line here just to help me break this up so I can see it a little bit more visually. When it's an acid, when we balance the O's, we're going to add H2O. And when we balance the H's, we're going to add H+. And that kind of makes sense. Acid is H pluses. So if that helps you remember, then so be it. All right, when we are balancing this equation, I have to add my oxygens by adding H2O. So in my Mn line, I have 8 O's on the left, so I'm going to need 8 H2O on the right. So now I'm going to add my H's to the opposite side because that's how we need to balance it. So 8 times 2 is 16, so I'm going to have 16 H pluses. Next line down, we're going to do the same thing. We have 10 O's on the left and we have 20 O's on the right. So over here, I'm going to need 10 H2O. And over here, I'm going to add then 20 H pluses. How you know you're doing this right? The H2Os should be typically on opposite sides. The H pluses should be on opposite sides. And we're going to simplify and make this, a lot easier to read. All right, we combine these two half reactions, and I am going to have to write small. So I have 16 H pluses here, and 2 MnO4 minuses here, 10 electrons. The next line down, I have 10 H2O and 5 SO2. On the other side of the arrow, I have 2 Mn plus 2 and 8 H2O, 5 SO4s, 10 electrons, and 20 H pluses. That just about fit. Okay, let's do some cancellation. I'm going to use blue to cancel. On the left, I have 16 H pluses, and on the right, I have 20. So this becomes 4 remaining H pluses. On the left, I have 10 electrons, and on the right, I have 10 electrons. On the left, I have 10 H2Os, and on the right, I have 8. So the 8 H2Os go away, and this becomes 2. Okay, so let's now see what's left. We have 2 MnO4 minus. We have 2 H2O, and we have 5 SO2, making 2 Mn plus 2s, 5 SO4s, and 4 H plus. If we did this correct, we have a balanced redox reaction. And I'm double checking my answer, and my answer matches what the correct answer is. And so now you can see that a redox reaction has some level of complexity. It also has a very rigid set of instructions, and sometimes it makes sense and sometimes it doesn't. You cannot see the transfer of electrons as easily, but it all works out, and this is how you do it. Make sure you take your time when you're doing redox reactions. Make sure you show lots of work and that you're able to cancel it. I will say on the test, when you're looking at these, if you're doing a long version of these and it's not just a multiple choice answer, when you're doing these, make sure that you break it down so that, you know, if you get partial credit for the work shown, that I can find your the work to give you some partial credit. If this is just a multiple choice answer, well then, you know, it's up to you what all you show. My suggestion, write it down, show the steps. That way you don't miss anything and you're sure your electrons and whatnot are all balanced. Good luck.